Hey guys, so we're going to have a master class on lactate. And in order to do that, we're going to go through the history of lactate because I believe a lot of the misinterpretation, the mistakes that we make today came from misunderstanding, let's say, that occurred in about 100 to 200 years ago in the early stages of understanding lactic acid, lactate, and all these things. And a main mistake that we see today is that all the work that was done in the lab does not seem to correspond to the same reaction that happens in the human body. One of the main reasons for that is temperature. This is something I'll do a masterclass on, and the importance of temperature affecting chemistry. That allows me to go into entropy and all that stuff, so that will be definitely another lecture. But in the meantime, I want to start the history of lactate by going at a very simple point that lactic acid and lactate are not the same. Where does the term lactic acid comes from? It comes from the Swedish chemist called Carl Wilhelm Scheele, I think. Scheele, however they pronounce it, right? In 1780, discovered and isolated lactic acid in a lab. About 100 years later-ish, in 1869, you had purification of lactic acid, which means we could actually have what is called optical isomer detection. Isomer detection, right? And so lactic acid became known, if you want, right? And so, so that was done in a lab. The problem we have with this is that in 1869 and 100 years before, what it did not have is the work pioneered in 1940 by Haldane about acid-base chemistry and physiology. This is a work he started to publish around 1940, in the middle of World War II, which means most of those discoveries were not really public until the 1960s, 1970s. So you could see that adapting all those organic acids that were decomposed in the lab 100 years prior were not really put into the proper context until 100 years later, 1960s, 1970s, by Haldane. And acid-base chemistry and physiology is very important because it shows you how those organic acids actually interact in the body. And so what we see out of that, once that work came about, is that you cannot have, thermodynamically speaking, you cannot have lactic acid in the body. It is impossible. The pH is around 386, 367 depending. You cannot produce lactic, thermodynamically speaking. It shows that you cannot produce lactic acid in a human being that has a pH between 6 to 745. You know, is it not physiologically possible? So you never have lactic acid per se. So the idea was glycolysis leading to pyruvate that goes to lactic acid, and lactic acid is decomposed into lactate plus hydrogen ions. That was what was formulated for the longest time. And so basically ignoring Haldane's work, by the way. So in the next videos, I'm going to show you that actually the end product of glycolysis is not pyruvate, it's directly lactate. So that you do not stop at pyruvate, that anaerobically goes to our lactic acid, and lactic acid is decomposed into lactate plus the hydrogen ion. That is what you're going to see in most books, but actually it's wrong. We see that thermodynamically speaking, we see that with the lactate shuttle theory, like I'm going to make the entire masterclass, a huge chunk of the masterclass about the mistakes that were done in that field, right? And importantly, you'll see that glycolysis is a huge part of all of this. So glycolysis, for the longest time, up until the 70s, really, were seen as lactic acid as a waste product, if you want that. Glycolysis would get to pyruvate, and then in anaerobic condition without oxygen, it would turn to lactic acid that would get decomposed in lactate and hydrogen ion. Again, this is not possible. You cannot have lactic acid into a human being. You can have it in a lab where it's decomposed, but the second you put it within a human being, it turns directly into lactate. The reason for that is that during ATP hydrolysis, you have through an enzyme, another reaction creates a phosphate transfer that gets into all this. And so that hydrogen ion is being taken care of almost right away. If you know exactly if you want to know exactly what I'm talking about, I'm going to refer you to a paper, a letter to editor that we posted on the Strong Fit library. That was sent to the paper Physiology, letter to editor, called Lactate, Not Lactic Acid, is Produced by Cellular Cytosolic Energy Catabolism. And they explain to you exactly this step right there that I'm talking about. I just don't have the will all the time to put it all on the chalkboard, but it's explained very, very thoroughly into this paper. So the main point being that, and again, glycolysis, we're going to go on the next one. The main point for this lecture, and then you get to check all that good stuff on there, is to understand that there is no such thing as lactic acid in the body. There is only lactate. Lactic acid will only happen in a lab. This is very important because you're going to see that problem being repeated again and again and again. For example, lactic acidosis does not happen the same way in a lab and in a human being. So lactic acidosis most likely is incorrect. Why? Because they were showing in a lab that lactic acidosis will, for example, diminish the rate of contraction of a muscle. I'll put studies to explain exactly what I mean because I'm trying to use simple terms. But that was done on muscle fibers outside of a human being, right? So the problem with that is, and then we saw that with also the calcium ions. There was the problem there, you know, that all the pumps, that calcium pump in that sense, the rate of contractility of the muscle, all that stuff happened in the lab. The second we took those steps, so what they thought was lactic acidosis into a human being at a body temperature of 37.2, those particular steps ceased to exist because there is a huge difference between having things happening in the lab and having things happening in a human being. Suddenly, because of, first of all, body temperature, which is a huge component of all this, and what they call in vivo versus out vivo, which means the whole system working as a whole, you see that most of basically things don't happen that way anymore, right? So most of those things were done in labs, but never actually done on human beings, and that created a number of errors that we're going to go over in this masterclass. So by the end of it, you'll have a clear idea of what lactate does in a human being. So not lactic acid in a lab, actual lactate in a human being, because that is the only thing that exists in the body is lactate. There is no such thing as lactic acid in human beings. Thank you guys. Bye.